Identifying proportional and non-proportional relationships in a table. So the first example, which team will win the race? Students examine situations to decide whether two quantities are proportional to each other by checking for a constant multiple between the measures of x and the measures of y when given in a table or when required to create a table. So you're looking for that constant k. So we're looking for k times x equals y. So we find that by doing y divided by x equals our k. Students study examples that are of relationships that are proportional and those that are not. So you've decided to run in a long race. There are two teams that you can join. Team A runs at a constant rate of 2.5 miles per hour. Team B runs at 4 miles the first hour and then 2 miles the hours after that. Create a table for each team showing the distance that would be run for the times 1, 2, 3, 4, and 5 hours. So here's our hours for each team. So team A starts out with 2.5 hours and then, or 2.5 miles, and then adds 2.5 each time. Team B starts out with 4 miles and then they run 2 miles each time. So the important information, we're saying constant rate, 2.5 miles per hour, 4 miles first hour, and then 2 miles per hour after. For which team is the distance proportional to time, and explain your reasoning. Distance is proportional to time for Team A since all the ratios comparing distance to time are equivalent. The value of each ratio is 2.5. Every measure of time can be multiplied by 2.5 to give the corresponding measure of distance. Explain how you know distance for the other team is not proportional. For Team B, the ratios are not equivalent. The values of the ratio are 4, 3, 8 3/3, 5 halves, 12 fifths, and 7 thirds. Therefore, every measure of time cannot be multiplied by a constant to give the corresponding measure of distance. If the race was 2.5 miles long, which team? Team B. If it were 3.5 miles long, still Team B. Because if I look, going back here, it's 2.5 miles is right here, so they'd be at 7. And then at 3 miles, they're at 8, and we're only at 7, or Team A is only at 7.5. 3.5 miles, we're still not there. Okay. Four and a half miles would still be, 4.5 miles. Let's go back and look. Oh, I'm thinking time. 4.5 miles is going to be up in here, and they're already there. So, still Team B. For what length of the race would it be better to be on Team B than Team A? If the race were fewer than 10 miles, Team B is faster because more distance would be covered in less time. Using this relationship, if the members of the team ran for 10 hours, how far would each team member? If the race was fewer than 10 miles, Team B is faster. Oh, this says 10 hours. Let me fix that. So for Team B, or Team A, if we take 2.5 times 10, we get 25 miles. For Team, so this is A. For Team B, if we do 2 miles per hour for 9 hours, plus the 4 miles they ran first. So here we're looking at 22 miles. So Team A would be the better team. Will there always be a winning team no matter the length of the race? No, there would be a tie, both teams win, if the race were 10 miles long. It would take each team 4 hours to complete the 10-mile race. This one's the same question. If the race were 12 miles long, which team? I would choose Team A because they would be finishing in about 4.8 hours compared to Team B, who finishes in 5 hours. How much sooner would you finish on the team compared to the other team? Finish by 2/10 of an hour. So 2/10, so 5 minus 4.8 is 0.2. So 0.2 times 60 is 12 minutes.